Recently, there have been some pretty heated arguments on social media where approaches like Rails Hotwire, Laravel Livewire, and Phoenix LiveView are critiqued in contexts where interactivity matters most, especially in the face of network latency. I don't want to get into the argument, but I'd like to show how it's possible to get something naive out the door, which is typically enough for a prototype, and then we can sprinkle in some client-side code when necessary to add polish. To demonstrate this, I decided to make a basic application that really shines in a client context, but I'm going to use Phoenix LiveView. It's an app to create and manage countdown timers. As with everything on this channel, the full source can be found on GitHub with a link in the description. I'll start out by showing how to build this app, then I'll do some refactors along the way. Look at the timestamps in the description if you want to skip to something specific. The timers app looks something like this. We've got a list of timers, each that are counting down until some specific date in the future. We can edit those dates. Maybe we're going to change this to 6:34 a.m. We'll see the dates update live. We can, of course, create new timers and see them inline. When we click into one, we can also see a timer here. It's not the best app, but I think it shows some of the things that we can do with Phoenix LiveView and then a little bit of JavaScript. So let's get into it. Most Phoenix apps start with mix phx.new. I'll name the project Countdown, and for simplicity, I'll opt into using SQLite as a database. We'll install some dependencies, cd into the project, run mix setup, and finally, I'll open up the project in my editor. With an empty project in hand, it's the perfect time to run a generator. So I'll run mix phx.gen.live. This generates some live views for a model. I'll set timers as the name of the context, timer as the name of my schema model, timers as the name of the database table. We're going to hold a name property, which will be text, and we'll store an end at, which will be a UTC datetime. So this will create a timer in the timers context. If I go into lib countdown timers, we've got this timer generated here. It generated a database migration. It generated some views. It scaffolded out a whole bunch of stuff. And as a result, it asked me to do two things. One is to register these routes. So if I go into router.ex, I can just paste these guys in. And then I need to run mix ecto migrate. And that's going to run the database migration, creating the timers table and making sure that it has the right columns. To run a server, I'll run iex-s mix phx.server. This will start my application on port 4000 by default, giving me this page. And now I can show you around what was generated. If I go into /timers, I've got an empty list. I can create a new timer, give it a name. Let's just call it test. And I'll give it a date time that is sometime tomorrow. Save that timer. We can see the end at. I can open up the single view, and I'm managing a timer that has 2 columns. So that's just general purpose scaffolding, but it's very clearly not counting anything down. It doesn't know what it even means to be the end of a timer. So let's build that out. So for our countdown timer, I'm going to put a formatting function in the timer module, which was generated for me. So if I type in something like def time until with a timer, we're going to get some Copilot suggestions. I'm going to ignore a lot of it, using it just when it seems to be valuable. So we're going to want to switch based on datetime.diff of the timer end at and UTC now in seconds. So when the duration left is less than 0, we just want to return all zeros. So let's see, duration, when duration is less than or equal to 0, let's put a 0 like that. Then for everything else, that seems like a very reasonable suggestion. I'll take it, Copilot. So now we've got this time until function. Obviously in a real app, you would write some unit tests. You probably just wouldn't trust what was regurgitated by an LLM, but in this case, I'm just going to take it. And then I'll go over to the timer live/show file. Live views always have a module and sometimes have a template in a separate file. In this case, we've got this one, which returns the table, and I'm going to add a new item to the table. And I'll call this ends in. Now it's going to guess, oh, timer.ends in. Incorrect. We want countdown.timers.timer.timeuntil, and again, timer. And now we can see that this timer ends in 16 hours. If I refresh, it'll be counting down, but it's not doing that live, and we want it to do it live. Back over in this show.ex file, this is the initialization of our LiveView, and every LiveView has its own internal state. Whenever these lifecycle methods are called, we re-render this template, and then if there's any diffs, we send them to the browser. I can choose to just store something else in this state. Let's assign time until will be timer time until, and we've got to extract this timer out a little bit higher in scope, assign the timer, and now we can read this value instead of calling the function inline. So now it'll just be at time until. Performs the same way, still doesn't refresh, but it gives us an opportunity to use this as state and refresh it over time. So whenever this lifecycle method is called, we want to schedule a timer that's going to represent 1 tick of our clock. So we'll do a send after 1000 tick. This will send a message to our LiveView process, and we can do something in response to it. So we're going to handle info. Info is the type of internal messages versus events, which are the messages that come from the browser. So when we receive a tick, let's set the time until property on the socket. And we know we're going to no reply that. And now we've got a countdown. But it only went once. What we need to do here is make it so that we schedule another tick another second from now. With that in place, we're counting down every second. Now, this would keep on going every second forever, even if the time is up, which is obviously not an ideal situation. So what I'm going to do is grab this time until output and move it a little bit higher. And then if time until is all zero or is not all zeros, then we know we will tick again. Then finally we do our little assign down here. And remember to close my if statement. And now we've got this countdown. So technically we have satisfied the requirements. We have created a timer. The timer is counting down. When it reaches a negative number because the time has passed, it will be at a 0 and we will stop processing that on the back end. There's obviously some problems with this. If I open up my DevTools and open up my network tab, refresh so that I can get my LiveView WebSocket, I'll see that every second there is a new diff coming in. And this diff contains the ends in and the time value that's being put in the DOM. This is very wasteful and would be even more of a problem if we had high or unpredictable latency between the client and the server. The server is also using unnecessary CPU and memory, keeping track of and updating the formatted value, doing all of that DOM diffing. It's not a good time. And finally, we don't even have that countdown timer back on the index page. If I go back to the main timers list, I mean, we could do it. We could set up a timer within here and call a format to all of these items, but it would get pretty ugly. And a few years ago, this may have been a dead end. You might have had to bail out of LiveView and into something like React or Vue. Luckily, Phoenix LiveView has an extension method that can be used in situations where JavaScript is valuable or necessary. So in the assets folder under JS, we've got app.js. This is the main entry point for the application's JavaScript and generally is pretty small. It just says, hey, there's a live socket. Let's start using it. but we can extend it. Since this is a brand new project and we don't already have any JavaScript hooks, I'm going to create a new hooks object and then pass it to my live socket. Now I can start registering different hooks, and I'll register one called countdown. So the way that a hook is structured is that it has a few callback methods. One of them is mounted, and this is given a reference to this.el as the element that the hook was mounted on. If I want the target time that we're counting down to, I'll do this.el.dataset.target. This will be the data-target attribute of the element. And let's set this on this.target. And then we will call this.tick, which will be a method that we'll have to write. So I'll create a tick method. And of course, we're going to need to have a formatter. So let's write a function. Format duration, seconds, and see what we get. Let's add a little comment and regenerate it. That looks pretty good, but I want it to also start with a leading 0. So let's ask it to left pad this. Cool, that works for me. So what tick is going to do is it's going to calculate the remainder between now and the target date. Let's actually parse this, since we're going to have a string in our data set. And then we've got a diff. It's going to divide by 1,000, and incredible. It's even calling this set timeout for tail recursion, just like I intended. The reason to use set timeout in a case like this, or the reason that I prefer to, over using set interval, is that they'll naturally just stop ticking whenever you don't call this set timeout at the end. So this early return will stop the loop. Of course, we can also set the reference here. So this.timeout, which will allow us to clean up a little bit better in the other lifecycle methods. There's a destroyed method where we can just clear timeout, this.timeout. And there's also an updated one where we can clear the timeout, and then we can just call this.mounted, which will start the loop again. This is what happens when the server pushes a new value and we're reinitializing our hook context. It kind of keeps us in sync. With this hook registered and set up in the live socket, I should be able to go to this show page, and let's add a span because we have to have an element to bind the hook to. We will give it an ID, and we'll give it a phx hook of countdown. And finally, that data target equals timer end at. We'll close out this span, save it. And well, we still have the server side timer going. So let's make sure that this isn't what's causing us to update. I'll just comment out this send after, refresh the page, and it looks like we are counting down. If I go into my network tab again and take a look at those messages, we only got the message once. So we have now ejected from the server side push requirement. We were able to prototype something, it worked, but it wasn't great. And then we were able to sprinkle a little bit of JavaScript on top in order to add this interactivity. Now that we have this in place, we can get rid of this tick forever. We can get rid of it down here as well, and go over to that list view. I'm going to create another timer, and I'll just give it some other time. I don't know, let's give it 11 o'clock PM. If I go into index.html.heeks and add a new column, I can call this ends in. And then I should be able to grab this same span from over here. And instead of at timer.endat, we're going to go timer.endat. And we need an ID that is dynamic so that the page can keep track of these different instances. So we'll just put the ID from our context right in there. And then finally, this time until, I'm actually going to leave it blank and not server render this right now. And now we've got countdown timers in our table using that same Phoenix hook. Now, all the React developers out there, all the Vue developers out there are probably like, but what about components? This doesn't encapsulate that behavior very well. We've got these spans that happen to have this hook value. This feels brittle. Again, it's not being server rendered. We could do better. And Phoenix LiveView has a way to do that. If I go into the components directory, there's this core components file. This module is automatically imported into all of my context, so it'll be a very quick place for me to prototype. I could set up a structure of different components and import them and delegate them as I need to. But in this case, I'm just going to go down to the bottom of the file and start defining a component for our countdown timer. This looks like a good place to put it. So we're going to have an attribute, and it's going to just be the timer. It's going to be a countdown.timers.timer, and we're going to set it to required. And then we'll create our countdown timer element. It takes assigns, and we're just going to grab this guy right here, sigil H, put the span in there, and instead of timer, we're going to go back to @timer in this context. @timer.id, let's call this countdown, and give it a quick doc string. Again, good enough for me in a prototype application. Now I should be able to go into the index over here and just run .countdown timer with a timer equal to the timer from this context, self-closing tag, and we no longer need this ID value. Now let's go update our show page to use the same component. We'll just bail this out, and we need @timer in this context. We could also clean up this state management because we no longer need to store this time until. When I refresh this page, there's just this momentary little flash while the JavaScript starts up, and we should be server rendering this. We are talking about a server rendering thing after all. So if I go into my component, this is super easy to do. I can just put in a countdown.timers.timer, time until, timer, and now we have server rendering in both locations. One more minor thing that just kind of bothers me is in setups like this, there's this little jitter side to side as characters have different widths. There's a little CSS thing that you can do, and there's a Tailwind helper for it, the tabular nums class. When I apply this class, it'll just make it so that these numbers all have the same width. Now there's no more shifting left to right, and because we're using components, it also updated over here. With a component in place, we can hide the details of how rendering and updates to the clock work so that this application mainly just thinks about server-side rendering, but every once in a while it might dip into a component that hides some details and some optimizations internally. There's a ton of things that you can technically build with LiveView. And when you want more control, you can always eject into JavaScript. At that point, you're just working with elements in the DOM. There's several methods baked into the JavaScript hook context, which are all available in documentation. Remember that you don't need to go chase every JavaScript trend to build great real-time apps. As front-end libraries start reaching into the back-end, know that Phoenix LiveView is prepared to reach into the front-end. What matters most is being productive and shipping code that delights your users. Everything else is just a series of opinions. This has been Code and Stuff. Thanks for watching.